Hi, my name is John. I'll be going over Chapter 7, McKeague for Trigonometry. This is the Chapter 7 test, and I'm going to be going over the even problems to help you understand how to solve some of these problems out. And hopefully about maybe 80% of the problems or similar to it will be on your test. So let's start the problem right away. It says that B is equal to 118 degrees and big C is equal to 37 degrees and little c is equal to 2.9 inches. I used the law of sines to find little b. So we're trying to find the length of little b. So what we want to do is we want to draw a triangle out first. Label those angles big A, big B, big C. Little b is the angle is 118 degrees right here. Big C is 37 degrees right here. And C is 22.9. And you want to find little b right here. The law of sines, LOS, goes something like this. The sine of angle B, over little b is equal to sine of C over little c, and this is the guy we're looking for. We're going to cross multiply. And so b times the sine of the angle C is equal to c, little c times the sine of the angle B. And to solve for b, we divide it by the sine of c. And now we're going to use our calculator. Before we do that though, we're going to put in our numbers here. Our numbers are little c is 2.9. Angle B is 118 degrees. And little c is 37 degrees. Don't forget, when you're doing your calculator and doing your calculations on your calculator, I'm going to show you just a little bit so you can get a little bit of better feeling. Make sure you're in degree mode right here. So make sure you're in degree mode. And so we're going to go 2.9 times the sine of 118 and parentheses divided by the sine of 37. And you don't need the end parentheses on this one right over here. And then when you press enter, it should give you approximately 4.3. So little b is approximately 4.3. We're going to do what's called a quick check on this. I hope you can see it a little bit better. I might change the settings around just a little bit just to make sure you get a little bit of better feel for this. It's not turning right now, it's fine. But anyways, what you want to notice is that this angle is the largest angle. This is the smallest angle. So since this is the smallest side, 2.9, that B should be the biggest side, which is approximately 4.3. So you know you kind of got it right. It has to always match up. Biggest angle, biggest side. Smallest angle, small side. Okay. Let's do number 4. Next problem. If A is equal to 24.7 degrees. And big C is equal to 106.1 and little b is equal to 34.0. It's got 3 significant figures right here. Find all missing parts. So we want to draw it out first, nice and big. I probably want to label C right there. That's 106.1. So that's little c, and that's the smallest angle right over here, so we'll call this A, 24.7, and little a equals what, and that's angle B right there, and so we want to figure out what little b equals as well. So big B, you just use your calculator. The sum of the angles of a triangle is 180 degrees, so you take 180 minus 106.1 minus 24.7, and you get 49.2. So B is equal to 180 minus 106.1 minus 24.7, and that should be 49.2. So we found B. And now you can find the, so we got little b right here. Little b was 34.0. And you could use the law of sines at this stage. So sine of A over sine of C over little c equals the sine of B over the angle B, which we found 49.2 over 34.0. And you can use the law of sines to figure it out. At the last step, what I want you guys to do is make sure that the biggest angle covers the biggest side, and the smallest angle right here should cover the small side. Okay? And etc. I'll let you guys finish up on this. Number 6, use the law of sines to show that there is exactly one triangle for which A is 42 degrees, little a is 29 inches, and B is 21. So we're going to draw this triangle out again. Always on this one, I want to label this angle A, which is 42 degrees, and little a is going to be 29, and B is going to be 21. So I'm going to label this side always 21, because we're always going to use that hinge effect. Well, they want you to use the law of sines, so we want to figure out what that was B, so that's big B right here. Sine of angle, it says use the law of sines, sine of B over 21 is equal to the sine of 42 over 29. You cross multiply, you get 29 times the sine of the angle B is equal to 21 times the sine of 42 degrees. You divide by 29 right there. That's how you get rid of that. How do you get rid of the sign? I'm going to use my nice different marker on this. You don't divide by the sign, you take the sine inverse of this. So when you take the sine inverse of that information set, you should only get like 1 degree. Let's see. Take the sine inverse of, I don't know if you can see this or not. Let's take the sine inverse of 21, sine of 42, and parentheses, divided by 29. And the domain error. Let's go to it. Something happened here. Sine inverse of 21, sine of 42, and divided by 29. Oh, what I forgot was I have to put one more parenthesis here, insert another parenthesis. This is sine inverse of the whole thing, not just divided by 29. Okay. In fact, I should have put parentheses here. It's called user input error. Let's try it again. Sine inverse of 21 times sine of 42, and parentheses divided by 29. Now I'm not going to even put that in parentheses. I should get a real nice number this time, okay? And I should get 28.98, which is approximately 29 degrees. And that's equal to B. The reason I know it's 29 degrees is because this side right here is much bigger. Little a is much bigger than little b right here. If it was smaller, like 20 or 19, it could actually hinge right here to make two triangles. So that's how I know 29 degrees, 180 minus that. If I go 180 minus 29, it would be 151. 151 plus 142. It's going to be way too big, so you only will be able to make one triangle. Okay. So let's get going. Let's do another problem. Number 6. We just did number 6. Let's do number 8. Okay. Find two triangles for which A is 26 degrees. 26 degrees. Little a is equal to 4.8, and little b is equal to 9.4. Okay, 4.8 feet, 9.4 feet. So we know that this angle has to be less than 90. You have the ASS situation or the SSA situation backwards. It's a bad word, you can't use that. So that's A right there, and that's little b right here, 9.4. We know that that's much smaller than 4.8, so we'll probably make two triangles here. Let's call this C, no B, because it's the opposite. And let's call this B prime right there. So you're going to end up making two triangles here. Here's the first triangle. And then the second triangle, I'm going to use pink. And it's going to end up being this triangle right here. Okay? Second triangle. That's the ambiguous case. I know you're having a little bit of trouble with the ambiguous case. Usually, I'll give you a little bit of a reason why that happens. It's the hinge effect. It's going to this side B, which is 4.8. It's going to swivel back and forth from this point right there. Call it angle C, or point C. So let's use the big triangles to figure out how the triangle works. We know that 9.4 is much bigger than 4.9 right here. That's little a, so therefore we're probably going to end up making one triangle, two triangles, even one triangle if it hits right here on this point, or no triangles if it's too small. Okay, so let's try to work it out. Sine of a over little a is equal to the sine of big B over little b. I'm just going to multiply by b right there. That gets rid of it. To solve for the angle, big B, I take the sine inverse of the left side. There it is right there. So let's draw it again. B is equal to the sine inverse of B, little b, which is 9.4, times the sine of A, which is 26 degrees, all over little a, which is 4.9. And using my calculator, sine inverse of 9.4 times the sine of 26 divided by 4.9. We get 57 degrees. Now let's redraw it just to make sure that you kind of understand what's going on. B is right over here, it's 57 degrees. A is right over here, which is 26 degrees. And this is 4.9, this is 9.4. And you can figure out what this angle C is by using angle sum for the 180. And you can figure out what little c is now by using the law of sines. We're about 3/4 of the way done. So let's try to find the second triangle and see how that works. That's the pink one, so I'm actually going to label this pink right here. The only difference this time is to try to find out what this angle is. That angle is the one that's going to kill you. Once you figure that out, the rest should be pretty simple. A, B prime, and then C right here. This obviously is that distance right here, 4.9, because it's hinging, going back and forth. That's 4.9. This is going to be 9.4. It's not drawn to scale. It's fine. Doesn't really matter. What else do we have? That's it. Well, almost. We have this, which is 26 degrees. So using the hinge effect, we know something about this triangle right here. We found out this angle right here, which happens to be 57 degrees. We also know that this side is equal to this side because it's an isosceles triangle. This is 4.9, this is also 4.9, which means that since these are equal, the base angles are equal. This happens to be, we found it, which was 57. This is 57. This angle is supplementary to that. So that's very, very important that you figure out what that is right there. So 180 minus 57. On my calculator, and B prime is equal to 123 degrees. Since you figure out what this is now, you can use that to subtract it from 180 to figure out what angle C is, and then from there you can use the law of sines to figure out what little c is. It's not that difficult. So you will have two triangles, the outer one and the smaller one. One of the things is this length, little a, has to be bigger than smaller